All right, good morning. Today is April the 8th, and this is geometric sequences. So a geometric sequence is very similar to an arithmetic sequence. The only difference is now instead of adding or subtracting our common difference, we're going to have a ratio. So this is a sequence of numbers where the ratio stays constant. All right, and that ratio we're going to call R. So that common ratio, what we're doing is we're finding it by dividing each term by its previous term. So in other words, with a common difference in arithmetic, we would be going from left to right. Here, I need you to think the opposite. I need you to think right to left, right to left, right to left. So determining whether these are going to have a geometric sequence or not all depends on what you're divided by. So if I take 10 and divide it by 2, or divide it by something, what do I get? That would be 5. And then 50 divided by 10 gives me 5, and 250 divided by 50 gives me 5. So yes, this is a geometric sequence, and R is 5. All right, that doesn't always work out. So if you look at this one, for number 3, 18 divided by 6 will give you 3, but then 24 divided by 18 would give you 3 halves. So immediately, we do not have a constant ratio. That ratio changes, so it's not a geometric sequence. That is a no. Also, you can have the signs change, right? So in number 4 and in number 5, our signs are changing back and forth. So your common ratio has to be negative since it's changing back and forth. For number 6, we have negatives here, but that doesn't mean our common ratio is negative. All of those are the same, so those numbers, the sign of them are not changing, so that is still going to be a geometric sequence with a ratio of a positive number, even though all of your numbers are negative. So when you divide negative 36 divided by 9, you'll get positive 4. Negative 144 divided by negative 36, you still get positive 4. So that's kind of how that works there. It's still a positive number. There we would have R equals positive 4. But for number 5, let's look at this one because this is a fraction. If you notice, when you go backwards, right, negative 40 divided by its previous term, that will give me a negative 1/2. So it is okay to have fractions. We can do the same thing here. 20 divided by negative 40 will also give you negative 1/2. And then negative 10 divided by positive 20 will give you negative 1/2. So it is perfectly fine to have a negative. It is also perfectly fine to have a fraction. In other words, so if your numbers are increasing from left to right, most likely your ratio is going to be a positive number that is, or not necessarily a positive number, but it's going to be greater than 1. And if your numbers are decreasing from left to right, like in number 5, that number is going to be a fraction. When you're dividing by a fraction, that makes those numbers bigger. So as we go left, those numbers will get bigger. But pretty much as you go right, if the numbers are getting smaller, it's going to be a fraction. As you go right, if the numbers are getting bigger, it's going to be a whole number. Well, not necessarily a whole number, but it's going to be greater than 1. Okay, and you can look down in the notes and practice those a little bit if you want. But the biggest thing is understanding how to get a geometric sequence. So we take this number and divide it by the first number. Negative 27 divided by 7 will give me a negative 3. The same thing here, negative 3. So if we're trying to go this way and fill in the rest of the sequences, we need to take that 63, and instead of dividing, now we're multiplying. We're multiplying to the right. So 63 times negative 3 will give me negative 189. So we multiply that by a negative 3. That will give me positive 567. Those are negatives. And then we multiply that by a negative 3, and that will be a negative 1,701. So you can keep going from there, and it is perfectly fine to have those numbers alternating negative. Also, for number 9, to find this, we'll do 4 divided by 8. So our ratio is 1/2. Multiplying by 1/2. In other words, 8 times 1/2 gives you 4. 4 times 1/2 gives you 2. So we'll do that again. 2 times 1/2 will give me 1. 1 times 1/2 will give me 1/2. And 1/2 times 1/2 will give me 1/4. So you notice that as we're going to the right, these numbers are getting smaller. So our common ratio here is a fraction that is less than 1. It is smaller than 1. Whereas number 7, as we were going from left to right, our numbers were getting greater, and our common ratio was something that's bigger than 1. And we kind of don't pay attention to the negative when we discuss that. So we do have the first term, and instead of using the common difference, now we're using the common ratio. Common ratio and first term. All right, so our formula that we would use here is a sub n to find any number in this sequence. It could be 5, it could be 100, it could be 1,000. We will plug it into this formula. We take the first, already put the equal sign. We take the first term and multiply this by the ratio raised to the power of n minus 1, okay? And if you'd like to put this whole thing in parentheses, that is perfectly fine too. But we are raising this to a power of n minus 1. So to start out with, we need to find the first term and we need to find the ratio. So for 11, we will take 9 and divide it by 3. That will give us 3. That's our ratio. And our first term is also 3. So we take we're going to write our formula for it first before we plug in the n of 7. 3, parentheses, our common ratio is 3, and we raise it to the n minus 1 power. So we're plugging in for n to find any term. And what they've asked us to do here is plug in for 7. So we're trying to find the 7th term. So instead of multiplying out times 3, times 3, times 3, just a bunch of times, we can go straight to the answer like this and plug it in 7 minus 1 up top. So that is going to be 3 times 3 to the 6th power. 3 to the 6th power, well, let's just go ahead and multiply all of that out. That's just 3 to the 7th power, and that will be 2,187. So this is a shortcut, especially if I ask you for 7, that's okay. You can just multiply it times 3 7 times. It's really not too difficult. But if I ask you for like 400, 1, I wouldn't do that with such big numbers, but 2, it will take you a long time to type that into the calculator. So this formula is really useful to go straight there. Okay, so I'll skip down a little bit. Let's do 13. So again, to find our common ratio, 200 divided by the term before it. So that will be 1/2. Our common ratio is 1/2, and our first term is 400. So we will plug that in. A sub n, our first term, multiplied times 1/2 raised to the n minus 1 power. And then we will plug in to find 7. 7 minus 1, which will be 6. So you will plug in 400 times 1/2, you can even do 0.5 to the 6th power. You'll plug that into your calculator, and that will give you your final answer of 6.25. And now you can use some common sense here. If you get some crazy big number and then look back at your sequence, these numbers are decreasing, right? So if you look at 6.25 and you're like, wow, that's really small. Yeah, it should be, because we're going from 400 to 200 to 100 to 50, and we're going to keep going down. We're continually decreasing. So it is going to be a smaller number. If you get something bigger than 100 or 400 or something like that, then you know you've done something wrong. All right, we'll do 17, where we have alternating, or where our ratio is going to be a negative. So we take this term, and the very first thing we do with it to find the common ratio is divide it by the term before it. So negative 12 divided by 6 will give us a negative 2. That is our common ratio. And then our first term is 6. So to set up an equation, we'll take our first term, 6, and then put negative 2 to the n minus 1 power. All right. Now, one thing I do want you guys to understand here, and you should know your exponent rules from last week, you cannot multiply the 6 and the negative 2 first. If in the previous problems you've been getting something that's not what I'm getting, it's probably because you're taking this 400 and multiplying it by 1/2 and then raising the whole thing by 6. That 6 is a booger. You remember me talking about that in class. These guys can't multiply. These guys can't hang out until the 1/2 gets rid of his booger. So you got to do the exponent first, and then you can multiply. All right? So now that we've got our equation set up, we will plug in 7 again. That will be negative 2 to the 7 minus 1, which I'm going to go ahead and put as a 6th power. So what we're doing here is we're raising negative 2 to the 6th power, and then we are multiplying it by 6. Don't multiply 6 times negative 2 and get negative 12, and then raise that to the 6th power. You're going to get a completely different answer. The correct answer should be 384. All right, so then we can apply this to real life, real world stuff. So a car's value, the older the car gets, the more the value depreciates. In other words, the more the value goes down. Right, so here is our table right here, and write a rule to represent this depreciation. Pretty much all we're looking for here is there's our first term, there's our second term, there's our third term, right? So this is the exact same thing as what we had before. They're just putting it in a table format right here, okay? So we have 10,000, 8,000, and 6,400. Our first term is obviously 10,000. And then to find the ratio, again, we would take this 8,000 and divide it by the term before it, which would be 10,000. Now, after dividing that out, we will get 8 divided by 10, and that will give us 4/5. Okay? So our rule for this would be a sub n. To find the nth term in the sequence, we put the first term and then 4/5 raised to the n minus 1 power. Now they ask us what will be the car's value after 10 years. So we just plug in 10 for n. 10,000, 4/5, 10 minus 1. All right, so obviously, look at these numbers. They are going down. If you get a value that is above 6,400, that doesn't make sense, right? We still have 7 more years to go here. That number should keep going down, and it should go down a lot, right? A 10-year-old car is not worth nearly as much as it started out as. So we would type all that into the calculator, 4/5 to the 9th power. And once you solve that out, you should get $1,342.18. We're going to round that if we need to 0.18 because we have dollars, and that's what we're using. So if you got any questions on that, feel free to pause the video or shoot me an email. But that is geometric sequences. The big thing here is now we are dividing each term by its previous term, and we're looking for the common ratio